Hello viewers, I am Kausalya. Today we are going to solve problem 8, 9 and 10 in exercise 6.2 in chapter 6 triangles. I start with problem 8. Using theorem 6.2, it is nothing but converse of BPT. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. Right. So here the thing which is given is, again we are discussing about a triangle, right? And let this be our triangle ABC. The line joining the midpoints of any two sides of a triangle, right? So this is one side AB and this is the other side AC. Let D be the midpoint of AB and let E be the midpoint of AC. Right. So the line joining the midpoints. So this is the line that join the midpoints of any two sides of a triangle. Right. So this line is parallel to the third side. So previously we have considered this side AB and this side AC. Now what is the third side? BC is the third side. Right. So here we have to prove that this DE is parallel to BC. Right. That's it. So again, first, a general introduction about the diagram. ABC is a triangle and D is the midpoint of AB and E is the midpoint of AC and DE is the line that joins the points D and E. Right. So, as it is clearly given, you see D is the midpoint of the line of the side AB and E is the midpoint of the side AC. Right. So therefore here, since it is a midpoint, we can write it as AD equal to DB. Yes or no? Because it is a midpoint, therefore AD, the length AD should be equal to the length of DB. So this is what written here, AD equal to DB. So when I move this DB to the left hand side, it occupies the denominator position. Therefore here it is 1, the right hand side part is 1 because we have nothing left over, so it is 1. So AD by DB is equal to 1. Mark it as equation 1. Again, when you look at the next side, you see E is the midpoint. So obviously AE is equal to EC, right? So when the value of AE is equal to EC, again the same thing, AE by EC will be equal to 1. So mark it as equation number 2. So here when you compare, you see the right hand side values are equal in both the equations. Therefore, obviously the left hand side term should be also equal. Therefore, you see AD by DB is equal to AE by EC. Right. So here what does this indicates? That is the ratio of the sides of the triangle. Right, ratio of the side of one side, ratio of the one side of the triangle is equal to the ratio of the other side of the triangle. So when the value of ratios are equal, then obviously you see DE is parallel to BC, that is the line that connects the midpoint of two sides of the triangle is parallel to BC. This side, that is the third side. How does this came? This comes by converse of basic proportionality theorem, right? So converse of basic proportionality theorem tells that when the ratio of the sides of the triangle are equal, then obviously the line joining the midpoints of the two sides of the triangle is parallel to the third side, right? Now problem 9. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that we have to prove this ratio, right? So here you see ABCD is a trapezium. It is given and the diagonals they intersect at the point O. And the next thing is AB is parallel to, this AB is parallel to this DC. And here I need to prove AO by OB, right, is equal to CO by DO. Fine. So to prove this, you see here we are making a line. We are constructing a line, right? So draw a line OE which intersects the side AD at point E. Right. So here when you look at this diagram, it is very clear, right? That is OE, this line is parallel to AB, right? And the same way, this line, the same line OE is also parallel to this DC or CD. So we had make a note of it, right? Just write that OE is parallel to AB and this OE is parallel to this DC. Now we are going to consider the triangle ADC, right? So consider this triangle. When you look at this triangle, just now we had made a statement, right? That is OE is parallel to this CD. That is this line is parallel to this line. So when you apply basic proportionality theorem, what it says, that is the ratio of the sides AE by ED is equal to AO by OC. Okay, when these two lines are parallel, then obviously the ratio of the sides should be equal. Right, this is what BPT says. So just write it, AE by ED is equal to AO by OC. Mark it as equation 1. Now we are going to consider the triangle DBA, that is D, B and A. Right, when you look at this triangle, you see this line OE is parallel to this AB. Yes or no? Obviously, yes. So again, when you apply BPT, what it says, that is DE by EA is equal to DO by OB. Right. So mark it as equation number 2. Right, not that as 2. Here we are taking reciprocal. Right, when you took reciprocal, you see DE by AE becomes AE by DE and here it becomes BO by DO. Right, because why, what is the need, why we are taking reciprocal here is, you see, when you compare the equation 1, here it is in the form of AE by ED. But here it is DE by AE, right? So I want the same like this. So that is the reason why I am taking a reciprocal. So once after taking the reciprocal, you see the left hand side terms are equal. Therefore, we can equate the right hand side terms. Right. So AO by OC is equal to BO by DO. Right. So we are equating the terms, and when you do cross multiplication, that is AO into DO is equal to BO into OC. So what we need actually, we need the ratio of AO by BO. That's why I am moving this BO here, which is equal to OC or CO. Okay, both means the same. CO by DO. So finally, this is the thing what we need to prove. So finally, we had proved this. So our last problem in this exercise, problem 10. The diagonals of a quadrilateral ABCD intersect each other at O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. So this is just the reverse of the previous problem. In the previous problem, we have to prove the ratio. Okay, provided the given figure is a trapezium, we have to prove that this ratio is true. But in this problem, the ratio is given, we have to prove that the given figure is a trapezium. Right. So again you see ABCD is a quadrilateral, and again the diagonals, they intersect at point O. Right. So the given condition is, you see AO by BO is equal to CO by DO. Here again we are doing a cross multiplication. So AO into DO is equal to BO into CO. So make it as equation number 1. Now again here we are drawing a line OE. Right. So this OE is parallel to AB and this OE intersects the side AD at point E. Right, the same thing. So again, when you consider the triangle DBA, right? So OE is parallel to AB. So here you can apply our basic proportionality theorem. So when you apply basic proportionality theorem, we have to take the ratios of the sides of the triangle. So this is one side and this is one side. So DE by EA is equal to DO by OB. Right. So this is the thing what we have captured. Now next we are doing a cross multiplication. So DO into AE is equal to DE into BO and mark it as equation number 2. Right. Now here we are going to divide equation 1 by equation 2. Okay, I'll tell you the reason why. So when you divide, you see what happens. The common terms get cancelled. And finally, we end up with AO by AE is equal to CO by DE. Right. So here like this. Now again we are making some arrangements, right? That is AO by CO is equal to AE by DE. So again when you look at this triangle, in triangle ADC, so we will move back to the figure. So here what is the criteria? What we got is, okay, this one AO by OC or CO. AO by CO is equal to, okay, this is equal to AE by ED. Right. So here this side is equal to this side. Right. So what does this says? This says that is by using converse of BPT. Right. The ratio of this side is equal to this side. So obviously this OE is parallel to this CD. Right. Right. Am I making clear here? And you see here this OE is parallel to CD. We had just now proved. And previously you see we had made a statement that OE is parallel to BA. Right. So you see this OE is parallel to CD and the same line OE is also parallel to BA. So finally we can conclude that CD is parallel to BA. Right. You see when the line, okay, when the side CD is parallel to this AB. So obviously we can make a statement that the given figure ABCD is a trapezium. Right. So finally you see quadrilateral ABCD is a trapezium. Right. So that's all in this video. If you have any doubt, let me know in the comment section. Thank you.